There's this tiny, basically invisible technology that's completely changing how we store our food. Today, we're pulling back the curtain on the nanotechnology hidden right there in your fridge and looking at how it's fighting a silent war against food spoilage. Oh, we have all been there, right? It's that moment of pure frustration. You go to grab some berries or veggies, and nope, they're already gone. It's a huge source of waste, and it's a problem that traditional packaging has been trying to solve for a long, long time.
For decades, the job of food packaging was pretty simple. Just be a passive shield, a basic barrier, a wall between your food and everything on the outside. But what if that shield could be so much more than just a wall?
I mean, really think about it. Imagine a world where your food wrap is actively killing bacteria, or the container itself changes color to tell you, without a doubt, that the food inside is no longer good. This isn't some far-off sci-fi concept. This is the very real promise of nanotechnology. And that's where nanotechnology enters the picture. It's the key to this whole next generation of food preservation, and it's all happening at a scale that is almost impossible to imagine. So what is nanotechnology? Well, it's all about engineering on an incredibly small scale. We are talking about rearranging materials at the atomic level, which can give something as simple as plastic wrap some pretty extraordinary new powers. And when you apply this tech to food packaging, you basically get three distinct types of upgrades. Each one builds on the last to create smarter, stronger protection for our food. First, you've got improved packaging, which is really all about building a much better wall. Then things get interesting with active packaging, which actually fights back against spoilage. And finally, you get smart packaging, which it can literally tell us when our food has gone bad. All right, so how in the world do these teeny tiny particles create such massive improvements? Let's dive in and start with that first level of protection. The first big leap forward is what we call improved packaging. So by mixing nanoparticles like nanoclay directly into plastic, you create a material that is just drastically better at its job. Think about it. Oxygen getting through can be cut by up to 90%. How? Well, it's all thanks to something scientists call a tortuous path. So this tortuous path, what does that even mean? Well, picture an oxygen molecule trying to get through normal plastic wrap. It's a pretty straight shot. But with nanoclay mixed in, it becomes a microscopic obstacle course. That molecule has to weave and wind its way around all these tiny platelets, which slows it down a lot. And that simple physical change is enough to make a huge difference in shelf life. Okay, so blocking stuff from getting in is great. But what if the packaging could do more than that? What if it could actively fight back? That's the whole idea behind active packaging. The material isn't just sitting there anymore. It's an active player in keeping your food safe.
And hey, this isn't just a theory in a lab. It's already out there on the market. Just look at some of these examples. The key ingredient you'll see over and over is nanosilver. Why? Because it turns out silver, at the nanoscale, has these incredible antimicrobial properties. So it's being used in food containers that say they keep produce fresh 3 to 4 times longer, and even in things like baby bottles to help control germs.
All right, now for the most futuristic application of them all, smart packaging. This is where the container doesn't just protect the food, it actually monitors it and communicates its status right to you. So how does it work? It's all thanks to these tiny nanosensors that are embedded right into the packaging. They can detect the specific gases that food gives off when it starts to spoil. So for example, a sensor could pick up on the compounds from fish that's going bad and change the color of a label. It gives you a clear, unmistakable visual sign that it's time to toss it. So far, this all sounds pretty amazing, right? We've got better barriers, germ-fighting power, talking labels, but there's a catch, and it's a very, very small one. And this is the big question. It's the one that has scientists and regulators really thinking. What happens if these powerful little nanoparticles, the very things that make the packaging so great, don't actually stay put? What if they can move out of the plastic and, well, into our food? This process has a name. It's called nanoparticle migration, and it turns out a few things can influence it, like heat, how long the food is stored, and even the type of food itself. Things that are acidic or have a high fat content can sometimes increase the chances of these particles getting loose. And this brings us right to the central challenge of all of this. It's about carefully weighing the incredible benefits against the potential risks. It's a balancing act. This slide really just lays it all out, the heart of the dilemma. On one hand, the promise is huge. way less food waste, much safer food. But on the flip side, you have the peril, the unknowns. If we ingest these particles, could they be toxic? Could they build up in our organs? The truth is, the long-term health effects are still a major area of active scientific research. To manage this, regulators are setting some pretty strict limits. For instance, European regulations have a general migration limit for all substances from materials that touch food. But here's the tricky part. Nanoparticles don't always play by the same rules as larger materials. So figuring out their specific risk is a really complex case-by-case process that scientists are still trying to perfect. So where does that leave us? What is the future of this powerful technology really going to look like on our grocery store shelves? You know, this quote from the Journal of Agriculture and Food Research really just nails where we are right now. Nanotechnology is absolutely at the front line, ready to be a huge force in food packaging. But the road ahead isn't entirely smooth. We're navigating a new frontier that has immense promise, but also some really important questions. And that leaves us with one final and I think crucial question. The technology to make our packaging smarter and stronger, it's here. The real challenge now is to innovate responsibly. How do we make sure that the same materials we create to protect our food also protect our health and our planet? It's a delicate balance, and it's one we absolutely have to get right.